Computers suck. All right, welcome. My name's Tony Albrecht. I work for Riot Games. And I wanted to do a talk about video game engines, right? Because there's something I work on, something I like, and I thought it would be an easy thing to talk about. I thought I could just find a nice little website that had a list of all the different engines and some interesting stuff about them. Bugger all out there. I end up spending a lot of time trying to find this information and collate it together, and I kind of went down a bit of a rabbit hole. So I don't know how long this talk goes for. We're going to find out. I also can't read my notes properly, so I'm really going to be winging it, which will be interesting. Third-party game engines are an assumed part of game development nowadays. Everyone uses them. Not everyone, but lots of people use them. They do a really good job of what they do. But there was a time, not so long ago, when every single game had its own engine. And every single game was an engine. So we're going to go way back into the history of video games. We're actually going to go back to about, this is going to give me fucking shit. It's not working in percent of view properly. So we're going to go way back. We're going to look at, well, what is a game engine, right? We're going to go back to the first video game. All right. Now, the first video game kind of, this is not doing what it's supposed to do. There's going to be lots of swearing in this talk. Yeah. Yeah, this is not doing what's supposed to. Damn Microsoft. Find the freaking mouse. And this is me not having enough time to talk. All right. So, okay. 1947. This is how far back we're going. This is each time I do a time, I'm going to talk about a couple of things that happened in that year. The transistor was invented in 1947, right? And one of the first games as such, video game's a strong word for it. Basically, it was a CRT, cathode ray tube. It's called the cathode ray tube amusement device. This is going to shit me no end. It was invented by two physicists, Thomas Goldsmith and Cecil Ray Mann. They basically built a circuit that allowed you to move an electron beam on the screen and hit like an overlay of planes or tanks or whatever you wanted on the screen. So all you do is twiddle these knobs, move the electron beam, point to a spot, and then you would change the focus yourself manually to cause an explosion. Right? Arguably the first game using electronic media. It was never actually made at that point, but they patented as a game at the time. Then, 1950, and I can't see my bloody slide notes. How do I do this? Yeah. All right. 1950 was Alan Turing published his Turing test. Is there a hotkey to continue? Yes, I can do that. This is causing me no end of grief. I'm really sorry. This is Bertie the Brain. Danny Kaye playing with it. It's 1950. It was a 4-meter tall computer. It was a demo for a new vacuum tube that a guy invented called the Adatron, and it was a miniature version of the vacuum tube. And at this fair, they had this game set up, and they had 3 difficulty levels, and you could actually play tic-tac-toe against it. And there was lineups for this thing. People loved it. Then, oh, god damn son of a 1958. Lisp was invented. Fortran was invented the year before, and the microchip was invented. Then, in 1958, there was a physicist called William Higginbotham. He worked on the Manhattan Project. And after that, he worked in a lab where they were trying to find peaceful uses for the technology that they'd developed for the war. And they had these yearly fairs where students would come along and see the lab. And he had this thing called a Donner 30, which is an analog computer. And basically, he figured what it did was it worked out trajectories of missiles and were able to calculate wind resistance and all sorts of effects like that. He figured out he could actually take that and plug it into a crow and produce a game called tennis. He made a tennis game out of it. Not Pong. This is predates Pong. He said, oh, God damn, son of a... Yeah. It might liven up the place to have a game that people could play which could convey the message that our scientific endeavours have relevance for society. The game was this, all right? Which is not bad, you know? This is the setup, okay? So that's you can see the little pads down the bottom there? They wired in and they could just change the settings for where your thing was, and they also could change gravity and wind resistance and all sorts of stuff. Now you can just see a little bit of text up there. If we zoom in on that, the computer is capable of much faster operation, but is programmed to operate at a pace which the eye may follow. They had to slow it down so you could play it. When was the last time you had to slow down your game so that people could play it? So, 1961. Excuse me while I swear at the computer and scroll down a little bit. In 1961, Algol was invented. COBOL was invented the year before. This was a revolution. It's a PDP-1, all right? It's 16 kilobytes of memory, 18-bit words, 18 bits. Did 100,000 ads per second, which is about 200 kilohertz. Weighed about 550 kilograms. What happened was MIT were getting one of these things, and they had a thing called the kludge room, where they could hack stuff and do interesting things. And they were trying to figure out what to do with this. This machine cost $120,000 in 1960, which is about $1 million nowadays. So these guys were sitting around figuring, what can we do with this? And they came up with the idea for Space War, a game. That was the first thing they wanted to do. And they built this game on it. It was 3 guys. I hate this computer. Right, one of them was Steve Russell. This is him in 2006 with PDP-1. There's a couple of those still working at the moment. There are only 55 PDP-1s ever made. Not all of them had monitors. So what's happening here is, that's Space War, running on a PDP-1. Basically you had ships and you could aim at each other and you could try and destroy your opponent. So it was head-to-head play. This game spread everywhere. Where there was a monitor, it would pop up. No, they're still giving me the shits, but I'll make it work. It's all right. It's going to take too much time. Yeah, thanks. The language used was assembly. This is from the PDP-1 manual, and it's quite recognisable as a early assembly language. Nice and simple, nice and quick to use. Alan Kay said, the game of Space War blossoms spontaneously whenever there is a graphics display connected to a computer. And there's some fantastic information on the web about how this game spread and how it got to all the different computers around the world. People were porting it, putting it on other machines, and it became a test for the PDP-1s. When they'd install one, they'd plug into Space War and see if it worked. And if it worked, they assumed that the hardware was working fine. And back in the time, computers were incredibly expensive, and you actually paid for the minute of processing time. So the only times when the computers weren't being used were the early hours of the morning. So the students would be in there at 4 a.m. playing Space War, because that's the only downtime that they actually had. So, 1971. I hate this computer. The Intel 404 was the first commercially available microprocessor, and email was invented in 71. And in 1971, it was estimated there were over 1,000 computers with monitors. 1,000. Next, what happened in 71 also was Space War. Nolan Bushnell and Ted Dabney, who went on to form Atari, wrote a version of Space War which was released in arcades. So it was the first video arcade game. It sold 1,500 copies basically, and it was too hard. People didn't like it. In 72, it's not the mouse, it's, yeah, sorry. Atari was founded, C language was developed in 72. First handheld scientific computers, calculators were released, making slide rules obsolete. And we had the, oh, that works. Awesome, I can do this. The first home video game console was released, which is the Magnavox. The Magnavox Odyssey. It's probably the first case of engine reuse. Here you can see them playing a version of Pong, and here, whoops, right, there we go. Here you can see them playing a different game, and another completely different game, and another game. The way they distinguish between the different games, they call them hockey and soccer and other bits and pieces. There'd be different numbers of bats and different balls and stuff. But what they'll do is they would actually cover the screen, your TV screen, with a transparent overlay, and that was your level. And this is not actually the Magnavox. It's a Fairchild, I think it is. God damn son of a... and that you can see that's a hockey game, obviously. So, then in 77, things started to heat up. Commodore PET was released, Apple II was released, TRS-80, and the 2600. Now, this little beast is 1.2 megahertz 6507 CPU, which is basically a cheap-ass 6502, 4K of ROM, bank switchable to about 32K ROM, and guess how much RAM? 128 bytes. Seriously, 128 bytes. That includes your video RAM. All right? So, this is, I love this shit. The way you did your graphics on this thing was you would actually, the way that the old CRTs worked was electron beam scanning backwards and forwards, right? As it got to the side, it had to go back to the other side till there was a period of time where there's nothing visible on the screen. So you had a 20-byte register that you could use, which was your frame buffer. And that could be repeated or it could be mirrored. So in between the physical electron beam going from one side to the next, you had to set up that register to put your data in there for the next scan line that was going to be drawn. All right? So you had effectively 40 pixels across, and you had to write to them every single frame in the H-blank. During your overscan, you could do a bit more game logic and set some other bits and pieces up. You had a couple of sprites that you could use. But it required a large amount of skill to make this thing actually work. And this was built, Pitfall. Look at the amount of detail in that. And you think about 20 bytes per scan line. You can see the symmetry in there. That rope is actually a single pixel sprite that's moved each individual scan line to the correct place. David Crane wrote this. This is in 1982, so they had a bit of time playing around with it by then, and he figured out how to do amazing things. He had a little running guy that he wanted to do a game out of. This was built. Given the small amount of RAM, this had 255 game screens. All right, and they compressed that. Basically, it's procedural generation into 55 bytes for the full 255 screens, which is impressive. Then in 1978, PowerPoint was invented. First x86 and Space Invaders was released. Space Invaders, you're all familiar with it, of course, right? They'd move across the screen nice and slowly, and as the game went on, they got faster and faster. The reason it got faster and faster was because there was less for it to process. So when it's moving slowly, it's moving as fast as it can, all right? It just happened to get faster because there was less happening, less to update. The early ones as well didn't have any color. You had like basically cellophane across the screen, so you could see the different colors on it in the arcades. It was awesome. 1982. The BBC Micro was released, the Commodore 64 was released, the ZX Spectrum was released, the TS-1000 was released. I'd never heard of it before. It was a $100 Timex Sinclair computer. It sold about 500,000 copies. It went insane, but 1 in 3 machines were faulty. It had no color, it had no sound. The keyboard had no keys, it was just flat and it was awful to use. You needed $50 memory expansion to actually do anything useful with it. Yeah, they blossomed and disappeared very suddenly because it was such a shit machine. And the 286 was released, and MS-DOS 1.25 was released in '82. Now, let me see. So, now, this baby. The video game crash of 1983 mainly hit the home console market. It didn't really affect home computers. So stuff like the 64 and the Spectrum and the BBC Micro and stuff were just still booming. This is the point where games started to reuse code. The games were written in assembly back then because these were 64K machines or less. You needed to write an assembly to get the performance you wanted to actually be able to have the game work at a decent rate. Successful studios were starting to reuse their engines, and they were putting out similar games after game. So they'd have a genre that they'd work within. In 1984, Apple Mac was released, IBM AT was released, and 68020 was released. That was a nice chip, I like that one. And Marble Madness came out. It was the first game written in C. It was written in an actual language rather than assembly, which was a watershed moment. And I discovered the guy that wrote this was Mark Cerny, who's the lead architect for the PS4. How cool is that? So writing it in C made it more portable. You could start to use, it wasn't an engine, this was a language you could use for multiple things. So this was ended up, it was in arcades, it was on the Amiga, the Apple II, Atari, 64, ended up on Game Boy, all sorts of stuff, because it became portable. In 1985, Commodore 128 was released, the Amiga, the Atari ST, the 386, Windows launched, DOS 3.2. So much of the stuff was happening back then. There's constant, the rich growth in technology, which is just astounding. Tetris was released in '85 as well. And this, one of the first IDEs for building games. It's called Painmaker. It was out on the Commodore 64. It was Gary Kitchen's GameMaker. It had scripting, it had a sprite editor, it had animations, it had a scene editor, it had a music editor. It even had an option to make a disc. So you put your disc in, you press a button, and it writes your game out to disc, and then you can send it off to a publisher and get rich. And I don't know that any games were actually released using this, but it's the first case of it, and it was reviewed wonderfully. People loved it. It was a great chance, a point where people could start to write their own games and experiment with technology. So, next, 1987. 68030 was released, the Mac II and SE were released, Amiga 500 and 2000 were released, Acorn Archimedes was released, MS-DOS 3.3 and Windows 2 were released. And this one. Maniac Mansion. Released in '87, the engine took about 18 months to 2 years to build. Ron Gilbert, who I think is supposed to be actually at this conference as well. Yeah, I got nervous when I realised that, and I was writing this slide. He wanted to do this game, and he was writing a 6502 assembly was proving too difficult. He realised he needed to have some form of engine which he could use to build this. So him and another guy put together this game engine. They want a system that could be used on many computers and cut down the time it took to make them. The engine allowed the designers to use a scripting language to build the game logic. The script would be byte encoded and then interpreted at runtime. Allowed them to do all sorts of stuff with the graphics, animations, and they kind of separated the actual creation of the game from the programming of the game, right? Which was awesome at the time. Spent a lot longer building the engine than they thought, but the engine ended up being used in a lot of games. Oops, sorry, that's the one there, and click this 400 times. So that was the Scum engine. There are other parts of the Scum engine, the other bits and pieces. There was sputum, spit, phlegm, mucus, bile, and cyst. That's awesome. And it powered almost all of LucasArts adventure games from that point on. Then in '87 as well was the release of Incentive Software's Freescape engine. It was used for a series of games. Driller was the first one on the Amiga, the Amstrad, even C64 and DOS. 3D engine, right? It had its own scripting language called FCL that you could use to do stuff. It went on to be used in about a dozen games before morphing into the 3D construction kit you see before you. It came with a 30-minute VHS tape and a tutorial by the author. And you can see it on YouTube, it's awesome. It had animation, collision, sensors, switches, conditions based on object interaction and all sorts of stuff. So you could build a fully functioning game with it. Graphics was fairly limited, but for the time, pretty amazing. Then in 1993, I hate this fucking... the Mosaic web browser was released, MP3 format was released, Windows NT 3.1 was released, and we also released Doom. All right. Now, this was... there were a few games around that time when Doom came out, doing 3D stuff. Ultima Underworld was a good example. Actually allowed you to look up and down, but it was in a very constrained little window. But Doom was doing stuff that was just out of this world. It worked, partially because of the brilliance of the coders involved in it, but using a chunky pixel mode that was available on your PCs that allow you to do very quick writing of coloured... It was the way that the video buffer was set up, which meant that it worked well on PC, but didn't work well on other platforms like the Amiga because of the way its bitmaps were set up. But fantastic game, very limited, and you couldn't actually go, like, there wasn't layers of 3D, it was all kind of this special 2.5D projection. But that took the world by storm. But one of the key things about this was not so much the engine, but the fact that it was released as shareware for the first 9 levels, and then if you wanted the rest, you pay for it. And that's what really made it take off. And that was used in heaps and heaps of games I'm not even going to read because it's so running out of time. So, in 1996, the first browser to support JavaScript was released, and the Voodoo 3D effects card was also released, which was awesome. I was going to bring mine along. I actually found it when I was cleaning my office the other day. Having a GPU that could do graphics for you was amazing. It was a big change in the way things were done. Quake was released with a 9-inch nail soundtrack, which was awesome. They built a whole new engine rather than using the Doom one because they wanted to do proper 3D, and this was proper 3D. They went on to make, initially it was software rendering, and it went on to be using Glide, and then using every other API under the sun. This is the family of games that spread from Quake. Used a lot. Now, this was really the beginning of we can make money selling engines, building engines that other people can use. This was a realization. In 1998, the 333 megahertz Pentium 2 was released, and Windows 98 was released. But also, Unreal was released. Okay, Unreal was used on Unreal Engine 1. It integrated rendering, collision detection, AI, visibility, networking, scripting, file system management, all into one engine. It did everything, right? It included a software rasterizer, but also went on to provide a hardware accelerated version. It was, sorry, I am really struggling with this. But in 2001, Unreal 2 came out, and then 2004, Unreal 3, 2009, UDK, 2012, Unreal Engine 4. Until 2014, Unreal was expensive, crazy expensive. Focused on AAA quality titles, first-person shooters mainly. It was driven internally by their flagship products, which worked amazingly well for them. But yeah, expensive. So 1999. Nothing happened in 1999, except COBOL programmers were dug up and reanimated to stop the world from exploding as their shitty old code broke when we flipped over into 2000. So, Painmaker Studio was released in 99. 2D-centric, easy to use, with physics, animation, audio, networking, and eventually monetization built into it. Full drag-and-drop IDE, designed to be nice and simple, and heaps of games are released on it that are actually pretty good. It's Spelunky and Hyperlight Drifter and Nuclear Throne, Undertale. Lots of really good stuff done with a very simple engine. Does what it does really well. 2000. What happened in 2000? Windows 2000 was released. PlayStation 2, that was a big changer. And the Pentium 4 was released, and first gigahertz chips were released also. Renderware was released earlier on. First games on Renderware about 1996. In the 2000s, with the advent of the PlayStation 2, lots of programmers were coming across from PC world and had to write games without using Direct3D, and they complained and whinged and moaned, and it was too hard. So Renderware provided a solution to allow you to get your games running on PlayStation 2, and it really took off at that point. Lots of game studios were using it. It was 2001 was when it really boomed with Grand Theft Auto 3 being released, and Tony Hawk Pro Skater 3 as well was released using that engine, and it was massive. But what happened was it got bought out, and EA bought it, and they said, we're going to support it. All you guys that are paying your license for this will still support it. Don't worry about it. Trust us. And then they stopped supporting it. Well, no, they kept the support, but they stopped developing the engine because basically Unreal was better than Renderware, and they couldn't catch up. So all the teams that were using this thing, all of a sudden, gone. No engine. So create a bit of a vacuum. And in 2005, this thing was released. Can you pick what this is? It's Unity. All right? Very early screenshot, Unity 0.2 beta, I think. And you're all familiar with Unity, so I won't go into it too deeply. But three guys decided they wanted to do something cool. They wanted to model it on Renderware, and they came up with this. Pivot point here was the introduction of iPhone support in 2008. That's when things really took off for it. That's when the engine started to really be used. By 2011, there was 750,000 users, and now there's about 5.5 million. All right, absolutely massive. That's something that's more familiar view. How are we doing for time? I passed. Cool. I'm so not going to get this ready. Right. At the same time as we had all these massive engines that do everything for you, we had all these specialist engine components that were being released and were surviving in this ecosystem. Havoc was a good one. It was released announced in 2000 at GDC, and is still successful. And all these bits and pieces, they provide a very fixed solution to a very specific problem. All right, and they do it really well. Except for Scaleform, that's shit. There's also these tools outside of that as well, like your Maya and all the other stuff you use to produce the content that you can put into your game. All those things are important. So, today, we're going to jump. I can't cover every single engine. There's too many out there. You know, you CryEngine, Frostbite, Lumberyard, Gamebryo, Marmalade, Game Salad, Ogre, Play Canvas, everything. It's all recent history. We're all kind of familiar with it. Mark Twain said, when everyone's looking for gold, excuse me, it's a good time to be in the tool making business. And that's what Unity, Epic are doing. There's Havoc, all those guys are producing quality products that we can use and making a shit ton of money out of it. We, as game developers, don't necessarily make a lot of money out of them, but it gives us a chance. So, what happened next? Well, one of the other reasons that Unity did very well was because it's fairly cheap. People could use it, and lots of people could use it. Unreal was crazy expensive. And then in 2015, this happened. They announced that it was basically free and open source. And then Unity was free for personal use. And then GameMaker's free-ish. And CryEngine was free, kind of, unless you want support. And then Lumberyard's free, but with source. And AAA games, game engines, they're free, effectively, you know? They do take your firstborn once the game's been delivered, but effectively free. Your barrier to entry is gone. Absolutely amazing. But one of the cool things, I think, and another pivot point really, was the asset store. Being able to build something and sell it within a game engine to other game developers. You're building tools that other people can use, right? And some of the tools are quite small. Some of them are massive. They provide detailed solutions for shortcomings in the particular engines. I think this can't be underestimated how important this is. Another thing about Unity that's really important as well is the whole user interface, the fact that you can customize that yourself to build your game builders, right? That stuff is critically important. More so than just, you know, being able to render a certain number of polygons per minute. So, what's my point? All right. I'm going to try and, in the next 10 minutes, get to a point. A little bit of recap. I'm going to throw in some observations that I've made in my research and these things that you still change. Jerry Lewis is great, isn't it? 1952. I think it actually goes to a point where he gets hit. Let's see. The movie's Sailor Beware. And yeah, so this is just, come on, hit him. Oh, yeah, we've got to move on. So I'm going to make some observations about it, try and wrap it all up, put it together, and make a valid point. So, is he going to hit him this time? Do we want to see him get hit? All right. Well, wait. Here we go. All right, I'll get to my point. Languages, actual languages, spoken languages, shape the way we think and determine what we can think about. This is Benjamin Lee Whorf said this, and he's was a linguist, and it's called the Sapir-Whorf hypothesis, I think. I can't quite read my notes. I think that's actually applicable somewhat to games as well. And Whorf actually comes from this guy's name. He was named after Benjamin Lee Whorf. The whole idea of a warlike society and their language being warlike and whatnot. Anyway, get to the point. I think a game engine shapes the way you think about your game. All right? You have certain sets of tools that are provided to you that you can use, and you need to build your game within those tools. They are the verbs and nouns that you construct your game from, which is why games have a certain flavour built on certain engines. They have a particular look. You can build games that don't look like the engine they come from, but that takes a fair amount of skill. Right? So if you are building a game, you have to take into account the engine that you're using. Those constraints are important. Constraints actually build the game. Having a game with no constraints is a recipe for disaster. So I want to have a Grand Theft Auto game, but with submarines, and you can knock down entire buildings and raise mountains and all this stuff. It'd be a fantastic game, but pretty much impossible to build. Without focus, without constraints, you can't build a decent game. Providing constraints and building a game within those constraints is a great tool. Game jams did that really, really well. Here's a theme, build a game. You can have one moving object, make it fun. Coming from game design from that point of view, I think is fantastic, in that you have you're taking an idea and making it fun, rather than saying, I've got a fun idea, and then trying to make that. Ignoring constraints can break a game. Now, is programming becoming obsolete? There are a number of games that have been released without programmers, which is pretty cool. But overall, God damn son of a... There we go. No. The logic involved in a lot of game dev, a lot of games, it requires programmer type logic. Even if you're wiring together blueprints and whatnot, it is still kind of programming. People that have started writing games that weren't programmers have come out the other end as programmers to a certain extent. We're always going to need to have programmers, so your jobs are safe, don't worry. But the beauty of these other engines, though, is that it allows people with that are less technically capable to actually put together games, which is fantastic. You get to see games that we wouldn't think of. Twine games and stuff are using a particular engine and you don't necessarily need programmers. So, are in-house engines dead? Okay, this is the top 1,000 games on the mobile games, and can you guess what the most popular engine is at the top there? No. In-house. All right. There are still more in-house engines than Unity. Unity 34%. Right. There we go. This is from the Unity website. All right. When you start to take into account PC games, I couldn't find stats on it, but I imagine there are a lot more in-house engines happening on PC as well. So in-house stuff is still very important. How are we doing for time? We've got 5 minutes. So let's talk about engine evolution, all right? Evolution is driven by problems and room and space to grow into. Successful solutions thrive and evolve as long as there's space for them. But if there's plenty of room, even substandard solutions can thrive. Our first problem was inventing a display, monitors. Once the monitors appeared, people were able to write games that used them. It's the first thing they did when they had monitors, which I find amazing. Then that was back in 1950s. Then we looked at the display of more and more content in the 70s. How do we draw all the stuff we want to do, your pitfall type stuff? How do we get this stuff happening? We're trying to solve particular problems, and it's programming problems. It required a high level of specialization and a lot of understanding of the hardware that you're running on. And that stayed with us up until the 2000s, really. Once we had display solved, basically the PS2 era, your Doom and Quake, rendering was working. People could write engines easily that did that stuff. Then the bottleneck shifted to content creation. All right, I'm putting more and more stuff in there. It takes longer and longer. I want better looking stuff. I want shaders, all that type of stuff. The content creation became a bit of a bottleneck. So we tried to solve those problems, looking at our IDEs and our game makers and stuff. But now we're getting to the point where it's kind of a solved problem, but we're putting more and more people into the same box trying to produce these games. And people are treading on each other's toes. So lots of artists trying to produce content and feeding that into a particular game. Lots of programmers working on content, and they're all trying to feed that in at the same time. So that's the problems that we're currently dealing with. So if we look at our current engine problems, design iteration. How quickly can you take a game and iterate on it and make it fun? That's critical. And the main engines out there are doing that, and they're doing it, it's getting better and better. But content conflicts are another issue. Multiple developers working on the same area, how do you make sure they don't conflicts, issues with bloody Unity and stuff. Lots of people working on the same field is a problem. Support is an issue as well. You have these massive engines that are growing and they can do absolutely everything. They're getting larger and larger. How do you ensure that you can provide the support to the people that need it? And I think that's an area that Unity is struggling with a bit. Providing open source is one way around that, but you don't want to be changing the source to fix your problems, and it requires a lot of experience to be able to read that source and understand what's going on. So the bigger your engine gets, the bigger your team is to build that, the harder support becomes, the harder QA becomes, all sorts of issues stem from that. And one point I missed from before as well about in-house engines. There's a good reason not to use third-party engines, and that's if you're building a game which is going to last for 10 or 20 years, right? Which is happening now. The game I work on, League of Legends, has been around since 2006, right? And that will continue to evolve over the next 10, 20 years. You don't want to be beholden to another third party that writes your engine and changes things under your feet. You need to be in control of what's going on. We release a new version every 2 weeks. If we had to deal with releases from Unity or Epic underneath that as well, it'd be chaos. Sometimes you need complete control. So, back to my point. Engine problems. Design iteration, I mentioned that. Content conflicts, support, and performance. The more general your solution is, the more layers of abstraction you have, the further away from the hardware you are, the slower it gets. You need to understand what the engine can do well, so you can work within those constraints and produce a good game that runs efficiently. Sometimes you just can't do what you want to do with a given engine. And sometimes it's too late. You've already built most of the game before you realize what the engine can't do for you. The most amazing achievement of the computer software industry is its continuing cancellation of the steady and staggering gains made by the computer hardware industry. Basically saying, like back in '50, the Tennis for Two game, they had to slow it down. It was too fast. This doesn't mean that we're shit coders, all right? Sure, some of us are shit coders, but we are providing more and more content, more and more levels of abstraction. We've gone from this to this, all right? Amazing steps in technology, orders of magnitude more complexity in this. The processes we're looking at here are not just how do we program better, it's also an evolution of game engines, of art, of design, of production and management, all this stuff. 100 people or so working on one particular thing. That is a massive evolution from one guy sitting down and writing Pitfall, which was also a massive thing, The problems are shifting, getting higher and higher. So, I promised to tell you what's going to happen in the future, right? So, we've seen that there's this evolution of game engines and that they are solving problems along the way. And we've seen that we have some problems with our current engines. So what's the next step? What's the engine of the future? I think that Unity and Unreal and Painmaker and things like that will continue to go for quite a while yet, and they will continue to evolve. But I think where it will change is the componentization of these things, the asset store, the app store that allows you to buy different bits and pieces from different developers and use them within your game. I think that lower and lower access, providing a new renderer, say you want a voxel renderer for a voxel type game, or you want a 2D sprite game, focus components that provide a solution for a problem that you have. You want a good AI system, you can buy one and use that. So what that requires then is the parent engine to be able to accept these low-level plugins to do what you want to do, and allow the crowdsourced development of technology to take over. What that means is that you have these smaller teams working on very specific things that provide the best solution for that one problem. Support becomes a lot easier because you're a small team working on a smaller problem set. Come on, stupid bloody computer. It doesn't make sense to support you as a user of a game engine. You're not doing voxel stuff, you don't care about voxel support. If you're not doing 3D stuff, you don't care about that support. But as the developers of the engine, you have to support all these things. It's a huge amount of weight. These engines have momentum, and it's very hard to change their tack at any one time. providing a simple framework that is an IDE that people understand, a process of building, importing assets, and that type of thing being a common base, I think is where things are going to go. You can choose the components to suit your game design then. No longer are you having to constrain your design to the particular functions of that engine. There was one more point that I had on my abstract as well. And it was, why don't cannibals eat clowns? It's because they taste funny. So, any questions? And my apologies for the stuff up with the slides and stuff as well, and the swearing that ensued. But yeah, any questions or, yeah? Yeah, you're building everything that does the rendering potentially, or using components for other bits and pieces. But yeah, so it's a framework. I agree. That was the slide from Unity. Blame them. All right. I wouldn't have put it there, you know. But yeah, those stats I thought were interesting. So effectively, that to me is it's an in-house engine, and so that means that the percentage is even higher as far as first-party developed engines. Than that graph really shows. So, yeah. Yeah.
I've seen Transistor interplay real-time collaboration with things. So there was like forum editors who were Collada was promising you can have multiple people editing for them at the same time. So it hasn't really come into fruition. Do you think they would be open to that?
I have actually seen an engine that does that. At a slightly higher level of granularity, where more people can be working on the same level at the same time and seeing other people's work pop up as you're testing it even. That has its own problems, and it's a design process issue. Our design tends to be focused on, you don't want to see other people's changes while you're working on your bit, because it can break your bit. So you do want to have that separation. But you want to get your bit in there, in the game, as quickly as possible so that it can be tested and verified. At Riot, we have fairly quick pipelines because, 2 weeks to release. So anything you write within 2 weeks, or probably a bit longer than that, is out in front of 100 million people. So I don't think you're going to have more people editing the same polygon, because it's just going to end up in fights. And artist fights are nasty. It's just scratching and biting and, yeah.
I've seen you talk about stuff for optimization through various C++ forums. Have you seen jump in both language, and what do you think of JAI?
I think it's a great little tool. I don't know that I'd want to use it. I think I'd probably want to write my own because it's a fun tool. You learn so much by building your own engines, and I think what he's doing is amazing in casting all the work that he's done. That takes a lot of strength of being very sure of yourself as a programmer, and that's something I think programmers struggle with. Is even getting code review is hard because they might think that my indenting is shit, or have I done something wrong? That I think being able to, what he's done there is fantastic in getting programmers to show their work and leading by example and saying, this is how I do things. I don't think that engine's a good idea and it will solve a particular set of problems. I don't think it's the way for every engine to go, though.
Do you think people use the language he's writing for the engine?
I don't know enough about his engine. I haven't watched. I've looked at bits and pieces of it and thought, hey, that's cool, and then gone done other stuff. So, up the back. Um, 20 years. I don't think it's one thing. I mean, I think when things are shit, people fix it because it's obvious that it's broken, and that's what drives this evolution. To the point now where rendering a biped on screen running around is quite straightforward to do in these engines. Whereas back in 2000, that required a lot of work and understanding of quaternions and animations and blending and how to put all this stuff together and rendering it. PS2, you had to write your own clipper, for Christ's sake. But as time's gone on and we've abstracted away these problems, they've become easier. And like I said before, I think the problems now are more about workflow than the content. I do remember seeing, when I had my first 3D effects card, I remember seeing Tomb Raider running on this thing, and it was mip-mapped and smooth and beautiful, and I thought, graphics is finished. This is the peak. It can't get better than this, right? But now you look at your Uncharted 4 and it's like, oh my God, this is as good as it gets. It can't get better than this. 10 years' time, we're going to see stuff that's just amazing. I mean, I haven't even touched on the whole VR, AR stuff. You know, there's a whole lot of things in there that are going to blow us away in the next 10 years, or it'll just disappear into a hole like it has before. But I'll do another talk in 10 years and we'll talk about that. All right, how are we doing for time? 10:02. Any more questions? Cool. If you want to chat to me afterwards, Kieran? Pay me a huge amount of money and sell it to EA. I think that my issue as a programmer, I don't do a lot of stuff with Unity and Unreal. I've played around with them a bit and released a couple of things. My issue has always been support. I think it's not very transparent what's going on sometimes, and it's hard to find solutions. You're relying on the users of the engine to help you, not the developers of the engine. So the forums are great. I think changing the way that you do support and providing, it's hard. They're too big. They're too big. You can't provide this level of support that you want to without dedicating a huge amount of money, and you need technical people to provide that technical support. And you want the technical people to be providing content for your engine to make it better, rather than sitting there and providing support. It's a really difficult problem to solve. But I think you should work on support and transparency of where things are going and why decisions are made. That communication with the users of anything, whether it's a game or whether it's an engine, is critical. So I think I vaguely answered the question. Yeah.
Do you think that it's like an interesting way or like a useful way to engage with it, or do you think it's still going to be a waste of time?
It could be pretty cool. I think if you're developing VR games, you really need to be in a VR view. But doing a 2D sprite game with a headset might be fun, but I think unless you can do something with the VR interface that you can't do normally, or you can do something easier, what's the point? You know, it may be cool for certain versions of cool, but yeah, no, I'd like to think so, but I can't see what that would be yet. Right, we're out of time. Okay, come chat with me afterwards, and I'll be at a bar somewhere. So.